Hello friends, this video on equilibrium part 30 is brought to you by exampeer.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. So now we'll talk about ionization constant of the weak acid. I told only weak acid and weak base we have the ionization constant. So we'll talk about the ionization constant of the weak acid. So let's suppose I have a weak acid HX. We will put in water, it dissolves into H plus and X minus ions. Correct? And Ka is called the dissociation constant of the weak acid. And how we got this value? Let's suppose we had some C moles of HX. Liquid we can ignore at T is equal to 0. And this was 0 and this was 0. At T is equal to equilibrium, what happened? This becomes C into 1 minus alpha. Let's suppose alpha is my ionization, degree of dissociation. And this becomes C alpha and this becomes C alpha. I want to write K. K will become what in this case? H3O plus ion concentration into X minus by HX. H2O we can ignore because the liquid, pure liquid. This becomes C alpha into C alpha by C into 1 minus alpha. This is nothing but if you see C alpha square is cancelled by 1 minus alpha. And that is what you have got, and this is called Ka. Just again, in case of water we get Kw, a fancy name. Here also we give a fancy name, that is ionization constant of weak acid, Ka. Right, just a fancy name, ionization constant of weak acid. And please note, it is also temperature dependent. So at a given temperature, this guy Ka, this ionization constant of weak acid, is nothing but it is a measure of strength of an acid. So the higher the value of Ka, the stronger the acid. Obviously, if you see, we have talked about this in the equilibrium. Higher the value of K, the reaction will go more in this direction, right? The higher the value of K, the reaction will go more in the forward direction. So if the K is higher, the reaction will go more in the forward direction, and you'll get more H plus ion concentration, and the acid will be stronger. See the same principles which we have learned in the equilibrium chapter in the earlier slides. We are using it here. So the K is more, the reaction goes more in the forward direction, you get more H plus ion concentration. So if K is more, the acid is stronger. So since we had the pH and it became a very fashionable term, we use the pH in other things also now. In pKa also, pKa is nothing but minus log of Ka concentration. So pH what was? pH was, P of H was minus log of H plus concentration. Here we have pK is nothing but minus log of K. Similarly, we'll learn about pKb also, because the pKh became a very, in fact pOH also is a term here. There's nothing but minus log of OH minus concentration. Right? Similarly, we have pKa, that is minus log of K. So this is some list of some ionization constants of weak acid at 298 Kelvin. This is just to say that these values are already known, and we have scientists have calculated these values. So if you want to use the numericals or in your chemistry research, you can use this. For example, ionization constant of hydrofluoric acid is 3.5 × 10⁻⁴, and ionization constant of let's suppose benzoic acid is 6.5 × 10⁻⁵. You can say that hydrofluoric acid is a stronger acid as compared to benzoic acid. You compare these two acids, hydrofluoric acid is a stronger acid because it has greater value of Ka, that means it dissociates more as compared to benzoic acid. So with the value of Ka also at a given temperature, we can tell that which acid is stronger and which is weaker. So let's take one question here. The question says the ionization constant of the phenol is 10 to the power minus 10. You have to find the concentration of phenol in 0.05 m solution of phenol. The reaction is like this: 6,6H5 plus H2O will be in equilibrium with C6H5 minus and H3O plus. This is aqueous, this is liquid, this is also aqueous. Correct. So it says that the ionization constant of this is this. What is the concentration of phenol in 0.05 m solution of phenol? That means at T is equal to 0, this was 0.05 m and this was 0 and this. At T is equal to some equilibrium, this becomes 0.05 m minus x. This became x, this became x. So K, if you want to find, is nothing but concentration of these square. So this becomes, I'll just write like this directly, x square by 0.05 m minus x. And this is nothing but 10 to the power minus 10. Right? So if you solve this, you get x to be 2.2 into 10 to the power minus 6. Thus I can say that my H plus ion concentration is nothing but 2.2 into the power minus 6, and my C6H5O minus concentration is also 2.2 into 10 to the power minus 6, and that is my answer. Easy one. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.